We all thought we witnessed history. A golden comet from another star, arcing across the void like liquid fire. We watched it shimmer against the black, not pale, not greenish like the comets we'd come to expect, but warm, surreal, gilded. It looked like something that had been sleeping for 1 billion years and woke up burning. And then it broke apart. Then into what looked like a slow explosion. Each glowing shard trails its own delicate spray of dust across the stars. The story was too perfect. An object from beyond our solar system, not only entering our space, but self-destructing in full view, as if the universe was giving us a show. For a few days, space itself felt cinematic, the kind of drama no science fiction film could quite replicate. Because this wasn't fiction, this was real, or so we thought. You've seen the images. They were everywhere. Thumbnails with jagged gold streaks, captions shouting, "Interstellar comet shatters. You're witnessing history." 3I. Atlas is dying in real time. Millions watched, millions shared. The visuals were stunning, but the meaning behind them? That's what made the moment feel sacred. Because this wasn't just a comet. It was the comet. The third confirmed interstellar object ever seen by humanity. A traveler from beyond our solar system. A ghost from another star. And now it was glowing, breaking, dying. Except there was a problem. Not a small one. The science didn't match the spectacle. Telescopes, equipped with spectrographs, weren't seeing fragmentation. Photometric models didn't show a loss of structural integrity. Spectral signatures weren't aligning with golden-hued dust emissions. And the coma? It wasn't golden at all. It was green. Silently, across labs and observatories, astronomers began asking, what exactly are we looking at? Because 3I, Atlas, the actual interstellar object, wasn't breaking apart, and it wasn't golden. But by the time that truth surfaced, the myth had already gone viral. Let's rewind. The first time the golden image appeared, it seemed too poetic to be real. A single glowing tail, wide and curved like a painter's stroke. The hue wasn't the pale white of water ice. It was deeper, closer to copper, or bronze, or gold. Some images showed the nucleus fractured pieces drifting slowly apart. Each one is bleeding dust in radiant trails, captured by telescopes in Italy, Chile, and Australia. Stacked, sharpened, annotated. The claim was clear. The interstellar comet is shattering after its close pass to the Sunday, and the internet obeyed the algorithm. The story leapt platforms Reddit, YouTube, Instagram, X, clips stitched with swelling music, reels captioned, "First contact, ends in collapse." Voiceovers whispered phrases like, "Dying messenger," "Interstellar farewell," "One last breath across the stars." It was everywhere. It felt inevitable, and if you saw it and believed it, you weren't alone. We did too, because it made sense, or at least it fit. 3I, Atlas, had been making headlines. It was the latest in a short, rare lineage of interstellar visitors after 1I, Oumuamua, and 2I, Borisov. It had entered the solar system on a hyperbolic path. It had passed perihelion. It was active. And now, with golden light and visible breakup, it looked like the cosmic finale we'd been waiting for. But something was off. For those watching closely, not just the viral feeds, but the real-time data. The pieces didn't fit. The golden dust didn't match the expected output of carbon-based sublimation. The tail dynamics weren't consistent with outgassing from 3I, Atlas's known trajectory. And most of all, the object being tracked as 3I, Atlas by professional observatories, was intact, still green, still stable, still interstellar. So what, exactly, were we all watching? This is where the real story begins. Not in the gold, not in the fragments, but in the illusion. Somewhere, two real events had blurred into one false memory. Two comets, two bodies, one viral myth. And the mistake wasn't malicious. It wasn't driven by deception or disinformation. It was something simpler, something far more common. A name, a few images, a moment of pattern recognition, and then a cascade. The same way the comet seemed to fracture in space, the truth had fractured too. And in its place, we built something that felt more satisfying, a narrative that glowed, Because here is the uncomfortable part. The images were real. The golden comet, real. The fragments, also real. Just not from the object we thought. Not from 3I, Atlas. Well, get to the real names soon, to the distinctions, to the science. But in this first chapter, we want to stay here, in the illusion, in the moment the internet watched a golden star ghost die, and didn't ask if it was the right ghost. Because understanding that feeling, how easy it was to believe, is the key to understanding what happened next. You weren't wrong to feel amazed. We weren't wrong to be moved. But we were all watching the wrong comet, and that matters more than you think. We were so sure the golden object streaking across the void wasn't just another icy rock. It was something different, something cosmic. It looked like 3I, Atlas, the interstellar visitor everyone had been waiting for. A glowing, radiant wanderer wrapped in gold dust and breaking apart in real time. You saw the images. So did we. Headlines didn't hesitate. Interstellar comet shatters. Near Sunday golden object. Fragmenting in space. 3I. Atlas is dying a beautiful death. The tone was reverent, almost spiritual. This wasn't just space news, it was an event. A cosmic spectacle wrapped in certainty and awe. And it felt good to believe it. You probably shared one of those posts. We don't blame you. They were everywhere. That breathtaking image, the one with a shimmering gold tail arcing like a solar flame, flooded every science forum, every space-curious Twitter thread, every headline aggregator. Even the mainstream outlets joined in. NPR, Reuters, Yahoo News. A golden comet? Breaking apart near the sun? With a dramatic tail shaped like a question mark. What else could it be? We were told it was 3I, Atlas. And for a moment, that answer was enough. Because think about what that meant. Another interstellar visitor, only the third ever confirmed, caught in a moment of glorious decay. Not just passing silently like 1I, Oumuamua. Not just drifting in a CO-rich mystery like 2I, Borisov. But visibly transforming, glowing, breaking, leaving a trail of golden geometry across the solar system, like some kind of celestial swan song. It made sense until it didn't. The first seeds of doubt came from the timing. The image went viral around the 14th of November 2025, but the closest approach of 3I, Atlas, to the Sun, its perihelion, was November 3. If this golden thing was the same object, why did the image surface nearly 2 weeks later? Shouldn't the breakup have happened sooner, at the peak of solar heat? We brushed it off. Maybe it was lag. Maybe the instruments had captured a delayed effect. Thermal cracking, sublimation aftershock. It sounded plausible. It always sounds plausible until the orbit maps show up. That's when the story started to split. One set of astronomers pointed to one orbital path, hyperbolic, tilted just a few degrees above the planetary plane, tracing back from outside the solar system. That was 3I, Atlas. The other, an inbound object, not from above or behind, but from within the ecliptic itself. Slower, dimmer, bound. That was something else. But in the viral narrative, these two objects became one. The glowing gold object that looked like it was breaking apart was never independently confirmed as 3I, Atlas. It was assumed, it was packaged, it was shared, and then it was believed. You felt the certainty in the comments. This is it. It's disintegrating, just like Ison. That tail is incredible. People weren't just watching, they were interpreting, matching the visuals to old memories of comet breakups, comparing shapes, looking for pieces in the dust. We were doing the same. Even professional scientists were pulled into the whirlpool. Some posted orbital overlays suggesting the image might match 3I Atlas's trajectory. Others urged caution. A few asked the uncomfortable question, what if this isn't the object we think it is? The doubt didn't stick, because by then, the meme had matured. The image had a name, a story, a timestamp, a caption that said, Golden 3I, Atlas, fragmenting near the Sunday. And we had moved on from asking if it was real to asking why it was breaking. That's how narrative works. The moment a picture pairs with a name, it becomes identity. And once identity fuses with motion tail, debris, glow, it becomes story. It wasn't just the public that believed. It was us, the watchers, the readers, the narrators, everyone who should have known better. We didn't wait for spectrometry. We didn't confirm orbital fits. We didn't ask which instrument captured the image. We just saw gold and said, that must be 3I. It's easy to understand why. The color was too unusual. Most comets, even the active ones, show green or blue gas signatures like cyanogen or diatomic carbon. Dust tails, when present, are white or yellowish. But this was luminous gold, a deep, fire-polished hue, more like metal than mineral. Some said it was an artifact of exposure. Others said it might be iron particles or sodium emission, but the visual impact overpowered the caution. It looked like a sculpture cast from light. It had to be real, and it had to be important. We projected meaning onto its glow. We painted metaphor onto its trajectory. A golden comet, crossing the sun's fire, unraveling into light. How could that not be the most important image of the year? But here's the uncomfortable part. We still don't know what it was. As the news cycles moved on, the image stayed. It became a symbol, not of interstellar science, but of how quickly certainty forms in the vacuum of narrative. That's why we're telling this story not to correct you, but to include you. Because if you believed it, if you shared it, if you thought, even for a moment, that you were watching an interstellar object glow gold and shatter into dust, you weren't wrong. You were doing exactly what we all did. Trusting the headline, trusting the image, trusting the frame. But space doesn't care about headlines, and orbits don't bend to our metaphors. So now we go back. Back through the light, back through the pixels and timestamps and orbital charts. Well, retrace the image that started it all, because something did break, something did glow, and someone mistook one comet for another. And now we ask, was that mistake innocent or intentional? We all saw it, the golden streak, the viral image, the debris stream curving away like a comet, disintegrating mid-flight. The color alone was enough to freeze your breath. But here is the thing. Science saw something else. You may not have noticed it at first. None of us did. But the deeper we looked into the telescope archives, the orbital models, the light curve data, the harder it became to hold on to what we thought we saw. Because when you cross-reference that golden image with the actual recorded data from 3I Atlas, a problem appears. Not a minor inconsistency, a fundamental mismatch. Let's start with the color. The viral image is drenched in warm tones, fiery amber, golden yellows, with a dust-like brightness you'd associate with metallic reflectivity. It looks almost sculpted by light. But when we pulled up spectrometry reports from observatories tracking 3I Atlas, something didn't align. The color signature from real telescope data? Green. More specifically, a prominent emission in the cyan-green region, likely from diatomic carbon C2 or cyanogen CN, both common gases in cometary comet. Instruments like the Lowell Discovery Telescope and amateur setups using RGB filters were detecting strong green signatures in the coma and faint blue in the anti-tail regions. No gold, no amber, no sign of deep yellow light scattering. You're probably thinking, so what? Maybe the golden image came from a different filter, or was color processed. We thought that too. But then we looked at where and when that golden image was captured, and things started to fracture. According to the earliest timestamps, the image first surfaced from ground-based skywatchers on or around November 1214, depending on time zone. But if you check the official ephemeris from JPL Horizons, 3I Atlas was already past perihelion by then, and moving away from the Sunday, not inbound, not in a pre-perihelion heat surge, outbound. Now here's the physics problem. Comets, especially interstellar ones, typically glow brighter as they approach the sun, not after. That's when volatiles sublimate, when jets turn active, when thermal stress fractures the outer layers. If the object was going to shatter from solar heat, it would have done so before or during perihelion, not 2 weeks after. So, why was the alleged breakup shown in that image happening after 3I Atlas had already survived its closest approach? We went back to the JPL trajectory, double-checked the orbital arc. The perihelion was locked, the 3rd of November 2025. Solar distance, just under 0.39 AU. The thermal load at that distance is extreme, over 7 times the solar irradiance we receive on Earth. If something was going to explode, that was the moment. But it didn't. In fact, telescope images taken just days after perihelion showed something startling. An intact nucleus. Meerkat's radio detection on November 7 confirmed outgassing via the OH 18 cm line. Vera Rubin's early November images showed a consistent light curve. Even amateur astrophotographers captured frames that, while noisy, clearly showed a still coherent object. So what exactly did that golden image show? We started tracing the provenance, image metadata, observatory logs, filter stacks, and that's when the second contradiction hit. The golden object wasn't following the same path as 3I, Atlas. Yes, the tail direction was broadly consistent with solar radiation pressure, but the curve, the angle, the dust geometry, it deviated. Subtly but measurably. 3I. Atlas was on a hyperbolic trajectory, entering the inner solar system from a high-inclination orbit. The golden object? Its tail curvature suggested a bound orbit, lying mostly within the ecliptic. Lower relative velocity, different orbital plane, different history. Now we had two problems. First, the color mismatch. Second, the trajectory deviation. Still, we tried to reconcile. Maybe the gold was an exposure artifact. Maybe the tail curve was exaggerated by projection. Maybe. But then the third anomaly appeared. No fragments. The viral narrative said 3I. Atlas was breaking apart, shattering, dying a beautiful death. And yet, no observatory reported actual fragmentation debris. Not from Rubin, not from Hubble, not from amateur observers watching night after night. We weren't just missing evidence of a breakup. We were seeing the opposite. Cohesion. The light curve stayed stable. The coma stayed symmetrical. No sudden flares, no rotational chaos. It didn't add up. Because if the golden object really was 3I, Atlas, and it really did fragment, there should be shrapnel, a cluster, uneven motion, multiple photometric peaks. But all we saw was a single nucleus, still jetting, still accelerating, still whole. So, let's recap what we now have. A golden image of an object allegedly fragmenting near the Sun. But 3I, Atlas wasn't golden. It wasn't fragmenting, and it wasn't even in that position when the image was taken. And that leads to the inevitable, unsettling conclusion. The viral image wasn't 3I, Atlas. You're probably feeling that creeping discomfort now. We did too. Because if it wasn't 3I, Atlas, then what was it? A different comet? A misidentified asteroid? A case of lens flare and hope? Or worst of all, a well-crafted mix-up that hijacked the attention of the entire astronomy community? Because here is the part no one wants to admit. We believed the image first, and asked questions second, not because we're naive, but because the image was beautiful. It fit the story we wanted. It matched the myth of cosmic drama. A golden interstellar visitor, breaking apart as it kissed the sun. That's the kind of story that writes itself. But nature doesn't write stories. We do. We now know that almost all the dramatic images, videos, and reports that surged across the internet in late October and early November weren't showing 3I, Atlas, at all. They were showing a completely different comet, C, 2024 K1, Lemon, and that changes everything. Let's step back for a second. There were two comets in the sky, not one, two. One was a returning periodic visitor, Comet C, 2024 K1, a long-period body from our own Oort cloud. The other, a true outsider, 3I, Atlas, the third known interstellar object in human history. And yet, somehow, their paths crossed not in space, but in public perception. We thought we were watching a story unfold in real time, a golden-tailed object streaking toward the sun, flaring in brightness, visibly shedding pieces, looking every bit like something out of science fiction. That object? That was C, 2024 K1, not 3I, Atlas. You weren't wrong to think they were the same. We weren't wrong either. Why? Because the confusion didn't start with us. It started with a simple, seemingly harmless mistake, a name attached to a photo. Here is what happened. In late October 2025, Comet C, 2024 K1, Lemon, began a spectacular brightening phase as it approached perihelion. It developed a long, shimmering golden tail, partly due to solar angle, partly due to the composition of the coma interacting with solar radiation. Meanwhile, 3I, Atlas, had just gone behind the sun entirely invisible to Earthbound telescopes. During this blackout window, images of Lemon began circulating on social media, but labeled as 3I Atlas. The timing was perfect for confusion. Astronomy influencers, media outlets, and even some amateur observatories reposted the images, praising how incredible 3I looked. Some even mentioned fragmentation in progress. The truth? They were commenting on a comet they couldn't possibly see. By early November, the mislabeling had gone global. Thousands of posts, hundreds of videos, and millions of impressions, all celebrating a golden interstellar comet that wasn't golden and wasn't even visible at the time. We fell for it, because the illusion was beautiful, because the name felt familiar, because 3I Atlas was already a myth in the making. But the universe doesn't care what we name things. It just moves. So how did we figure out the mistake? We started comparing the image timestamps with official ephemerides, the real-time position logs from JPL, and the IAU Minor Planet Center. And that's when the curtain dropped. Every golden image, every fiery tale, every viral shattering sequence was pointing at coordinates that didn't belong to 3I Atlas. They matched C 2024 K1 Lemon, a comet that in many ways stole the spotlight without even trying. And in the midst of this chaos, 3I Atlas reappeared from behind the Sunday. What do we see then? Nothing golden, no fragments, just a strange, solid, whispering object with a faint ion tail and an entirely different story. This isn't just a naming error, it's a cautionary tale, because the deeper we look into this mix-up, the clearer it becomes. Our perception of space isn't just shaped by science, it's shaped by timing, media flow, and the fragile trust we place in labels. Let's be clear. C 2024 K1 is not 3I Atlas. The International Astronomical Union, IAU, gives every comet a unique designation based on its discovery date and nature. C 2024 K1, a non-periodic comet discovered in May 2024 by the Mount Lemmon survey. 3I Atlas, the third interstellar object ever discovered, first seen in 2023, on a hyperbolic trajectory from beyond our solar system. Their orbits are not the same, their compositions are not the same, and yet for weeks they were merged in the minds of millions. Let's explore why that happened. C 2024 K1 was in the sky, bright, photogenic, and extremely active. 3I Atlas was hidden, silent, unobservable, mysterious. Which one was easier to show? Which one was easier to share? Which one gave us something to see? The answer is obvious and human. We reach for images, we crave drama, we want evidence with our excitement, and when something looks dramatic enough, we sometimes stop asking if it's accurate. But the damage didn't stop at public misperception. Some early scientific discussions online, those relying on viral visuals, started misattributing the behavior of C 2024 K1 to 3I Atlas. Spectral analysis, color temperature estimates, fragmentation models applied to the wrong object. That's how fragile our chain of inference can be. One mislabeled image, one viral post, one careless assumption, and suddenly, the world is watching the wrong comet. The truth? 3I Atlas is still intact, still cold, still, unlike anything we've seen. It didn't turn gold. It didn't shatter in the way C 2024 K1 did. It doesn't behave like typical comets, and maybe that's the real reason we were so quick to borrow someone else's drama. Because 3I isn't spectacular in the usual ways. It's subtle. It whispers through chemistry. It flickers through geometry. It tells its story in shadows and slow curves, not fireworks. And maybe that's harder to go viral with. But now, we know better. You know the names. We've corrected the record. The next time you see 3I Atlas trending beside a glowing, crumbling comet, pause. Ask where the data came from. Ask where the image came from. Because in this case, the truth wasn't just different. It was a different comet altogether. And the real one, the interstellar one, is still out there. Still flying. Still watching. We've followed the light for weeks now. But here is where the story splits. Because the golden comet that dazzled the internet wasn't interstellar at all. It was born right here. A child of our own star. Its name, C 2024 K1, a solar system object, and the more we looked into it, the more extraordinary it became. At first glance, K1 didn't seem like much. It wasn't on the media's radar. It didn't have a mystery origin. It didn't come screaming in from deep interstellar space. But it had something else. It had gold. Not real metallic gold, of course, but an optical gold, a glow, radiant and warm, the kind that seems to pulse with heat even through the cold vacuum of space. Let's rewind to early October. C. 2024, K1, was already on a path that would take it extremely close to the Sunday. That kind of proximity is dangerous. The energy input goes exponentially. For most comets, it means rapid heating, gas release, and sometimes violent fragmentation. For K1, it meant transformation. From a pale dust ball in the outer solar system, it evolved into something spectacular. Its dust coma thickened. The solar wind sculpted its tail into shimmering arcs. And then came the gold. As the sun's light scattered through its dust, especially near perihelion, something unexpected happened. It began to reflect in longer wavelengths. Not blue, not green, but amber, copper, flame. You probably saw the footage broadcast across TikTok, Reddit, and Instagram. A glowing comet with long arcing tails, shedding pieces in slow motion. Some users called it the Golden Dragon. Others thought it was burning up. But most of them thought it was 3I. Atlas. That's where the confusion deepened. Because K1 and 3I were both visible around the same window. They were both active, both had tails, but one was glowing and the other wasn't. K1 passed its perihelion, its closest approach to the Sun, at a perilous distance. That proximity led to thermal stress. We now know that sometime near that pass, the nucleus began to fragment. Large chunks separated, each trailing its own mini-jets, and under high magnification, that breakup took on a majestic shape. Imagine this: a central golden glow, trailing smaller gold flecks behind it, all orbiting slightly offline, like embers behind a flame. No wonder people believed it was something special. They were right. Just wrong name. Astronomers tried to correct the record. Several posts on Twitter, now X, clarified the IAU designations. They showed side-by-side orbital charts. They demonstrated the inclination difference. K1, a low-inclination comet hugging the solar plane. 3I, Atlas, a high-angle interstellar visitor. But by then, the story had gone viral, and virality resists correction. Still, if we strip away the mislabel, C. 2024 K1 remains one of the most visually extraordinary comets we've seen in years. Why did it turn gold? This isn't just a metaphor. Color in space has meaning. It tells us about size, composition, and scattering angles. In K1's case, the warm gold hue likely resulted from forward scattering through a dense, fine-grained dust coma. The angle between Earth, the comet, and the Sun created a phase geometry where golden wavelengths dominated. Combined with the sheer density of particles near perihelion, the light shifted from standard bluish silver to an optical gold. There's precedent. Comet McNaught in 2007 showed a similar phenomenon. Golden tails formed from solar-aligned dust fans. But even McNaught didn't shatter quite like K1 did. So let's talk about the breakup. K1's fragmentation wasn't instant. It happened in stages. First, a brightening, then a diffuse elongation, then discrete knots of light began to appear, each tracking slightly off course. Professional observatories saw this first, but amateur astronomers with stacked DSLR exposures captured the unfolding sequence. By late October, K1 was no longer a single comet. It was a cluster, a debris train, trailing pieces, each glowing. And yes, in some frames, the fragments still shimmered gold. We don't know yet how many pieces survived, but the visual record is clear. A substantial breakup occurred. Not total disintegration, but a cascading stress event, likely triggered by internal pressure from sublimating ices. Interestingly, the core fragments remained relatively aligned. This suggests a low-velocity breakup, no explosion, just slow cracking. But it created an illusion. To casual viewers, it looked like a spectacular, elegant explosion in space. And since the color hadn't faded, the pieces seemed like glitter drifting in formation. You probably remember the viral captions. Interstellar object breaking up. Alien probe disintegrates. Gold comet cracks open. All wrong, but all emotionally right. Because what people felt was real. That mix of awe and sorrow, of beauty at the edge of destruction, of watching something ancient drift into oblivion while glowing like fire. That's K1's legacy. So where is it now? Fading. The gold has dimmed. The fragments spread apart. Its brightness has dropped below naked eye levels. But for a moment, a few hours, maybe days, it was the most beautiful object in the sky, and almost no one knew its name. We're not here to blame anyone for the confusion. The mislabeling was natural. 3I. Atlas is a more famous name. Interstellar gets more clicks, but we owe it to the science and to the sky to tell the story clearly. C. 2024 K1 turned gold. C. 2024 K1 shattered. And C. 2024 K1 deserved to be remembered on its own terms, because in the era of viral space footage, truth can shimmer quietly behind the hashtag, and sometimes the real wonder is the one we almost missed. Let's not miss it again. We watched something no one expected to see, not because it was bright, not because it shattered, but because it came from somewhere else. 3I. Atlas is only the third known object in recorded history to arrive from outside our solar system and pass through it unbound by gravity, unclaimed by any orbit. The 3I stands for Third Interstellar, following in the faint wakes of 1I, Oumuamua, and 2I, Borisov. But unlike those first two, this one did something different. It whispered instead of shouting. It moved slowly, passed close to the sun, and didn't behave the way either of its predecessors did. It was quieter, more patient, and more confusing. You're watching something extraordinary, an object born under a different star, shaped by conditions we've never directly measured, is now threading through our planetary plane, just a few degrees off the ecliptic. That's rare. Most interstellar visitors skim high above or far below our solar system's flattened disk. But 3I, Atlas, approached almost T-bone-style crossing paths, not grazing the edges, and it's because of that unusual geometry that we're able to see it better, for longer, than any previous interstellar traveler. What makes it interstellar? We don't just assume, we calculate. 3I, Atlas, follows a hyperbolic trajectory. Its eccentricity, how far its path deviates from a closed elliptical orbit, is above 1.02. That's not just a curve, that's an escape. It means 3I. Atlas is not in a loop, it's in a flyby. Its speed, its angle, and its lack of a gravitational anchor all say the same thing. This object wasn't born in our backyard, it's passing through. Just once. That one pass, however, is telling us a story worth listening to. Its green coma isn't just pretty, it's diagnostic. When we saw 3I, Atlas emitting green light, we didn't just marvel, we analysed. Green comas are typically caused by diatomic carbon C2, which fluoresces under sunlight at specific wavelengths. But in the case of 3I, Atlas, there's more. The object also emits carbon monoxide and, more intriguingly, carbon dioxide at levels far higher than average comets. Let's pause on that. Most solar system comets have a water-dominated profile. H2O makes up the bulk of their sublimated gases as they heat up. But 3I, Atlas doesn't follow that recipe. Preliminary spectroscopy suggests a CO2H2O ratio well above 2:1, and in some analyses as high as 5:1 or even 8:1. That's not just unusual, it's alien. That chemistry tells us something about where it formed. Comets rich in CO2 likely originated in extremely cold regions where carbon dioxide ice could accumulate in dense layers. But to retain that ice over billions of years, the comet must have avoided close encounters with any star, including ours. This implies a quiet, cold life until now. When we watched 3I Atlas pass near the Sun, something remarkable happened. It didn't explode, and that's shocking. Think of 2I, Borisov, our second interstellar comet. As it approached the Sun, it flared dramatically, fragmented, and released vast clouds of dust and gas. It behaved like an overcooked snowball, volatile. But 3I Atlas? It held together. There was no coma explosion, no sudden outburst, No tail spray is wide enough to suggest internal fracturing, just a steady, minimal release of gas. It was too quiet. And quiet is strange when you're that close to the Sunday. At its perihelion, 3I, Atlas, came within a distance of just 0.35 AU from the Sun, closer than Mercury. At those temperatures, ice should boil, jets should erupt, and fragments should peel off. But instead, 3I, Atlas, stayed intact. It glowed green, maintained a slender antitail, and kept moving. That restraint told us more than any explosion would have. It said, "This isn't made like our comets. Its surface must be tough. Its crust must be sintered. Its internal structure is either deeply cohesive or unusually inert. In either case, this is a visitor who resists drama, and that makes it harder to understand. You might be wondering if it didn't do anything flashy. Why do we care? Because restraint is a form of signal. In science, what doesn't happen is often just as important as what does. If a comet should explode based on our models and it doesn't, then something about our models is wrong or incomplete. That's why 3I, Atlas, is valuable. It's not just another visitor. It's a quiet challenge to what we thought we knew about how small icy bodies behave under extreme conditions. And there's more. Unlike 1I, Oumuamua, which was too small and fast to observe in detail, and unlike 2I, Borisov, which fragmented so quickly we couldn't study it up close for long, 3I, Atlas, is slow, stable, and large enough to observe with continuity. That means we can stack its data across days, across telescopes, across instruments. Every new orbit solution sharpens our understanding. Every new spectral reading refines its profile, and every image tells us a little more about the strange balance it holds between foreign chemistry and native physics. We're building a case, not just a memory. Each time we point a radio array or a wide-angle imager at 3I, Atlas, we're not just watching a comet, we're interrogating a relic. This thing could be older than Earth. It may have formed before our solar system settled into its current shape, and now it's here crossing our space, shining green in the void and holding its structure where others would have shattered. You're not just observing, you're participating. This is the first time in human history we've had 3 interstellar objects in our records, and 3I, Atlas, is the most cooperative one yet. It's not hiding behind speed, it's not dissolving in gas, it's just there, whispering its differences, waiting for us to ask better questions. And the more we look, the more we notice something uncomfortable. This isn't the comet that turned gold. This isn't the one that fractured. This isn't what people thought they saw. And that means something deeper, because if 3I, Atlas, didn't do what the viral videos claimed, then we have to ask, who did? We thought we were watching one story unfold. A golden object lit up the feeds, frayed at the edges, shimmered against the black, and seemed to unravel before our eyes. The comment section surged with one name, 3I, Atlas. It was a name that had already carried weight, interstellar, rare, scientific. But now it was being paired with visuals of gold dust and breaking ice. Even astronomers, in passing tweets or interviews, slipped between identifiers. And the result? Confusion, not just in the public but across headlines, visuals, and even some observatories. You weren't wrong to think it was one comet. We weren't wrong to feel something didn't line up. Because the truth is, 2 entirely different comets were lighting up the sky at the same time, in overlapping regions of visibility. Both dynamic, both beautiful, but only one turned gold. Only one was from beyond our solar system, and somehow they got entangled. Let's break it down. It starts with timing. In the latter half of 2025, a relatively obscure, dynamically new Comet C, 2024 K1, began approaching perihelion. This comet, part of our own solar system, had spent eons in the distant Oort cloud. But as it curved inward toward the sun, solar radiation did what it always does to fresh ice. It energized it. Around the same time, another object, 3I, Atlas, was cutting through the solar system on a path almost perpendicular to the planetary plane. It wasn't just new to us, it was new to the Sunday, new to everything here. We had detected it early, tracked it long, debated its status. And then, just as its journey was reaching a critical point near the sun, so was K1. 2 comets, 2 origins, 2 appearances, but the same sky, the same season, the same viewing windows from Earth, and only one name, repeated everywhere, Atlas. That's where the naming system comes in and where the entanglement begins. The Atlas system, Asteroid Terrestrial Impact Last Alert System, is an early warning network designed to spot near-Earth objects before they become dangerous. It does its job well. In fact, it detected both comets in question. But naming conventions don't carry tone, context, or clarity. C. 2024. K1 was tagged as an inbound solar system comet by Atlas, hence its Atlas label. 3I. 2025. Q2, the interstellar object, was also discovered by Atlas, and for a while simply referred to as the new Atlas object. When the International Astronomical Union, IAU, finally designated it as 3I Atlas, they did so using a system that had already been applied to 1I Oumuamua and 2I Borisov. 3I signified the third interstellar object ever observed passing through our solar system. Atlas indicated who found it. Perfectly logical, disastrously confusing. From that moment forward, 2 different comets carried the Atlas brand, and visually, they were even harder to separate. That's where visibility overlap sealed the mistake. In late October through early November 2025, both comets became visible to Earth-based telescopes and skywatchers. They weren't in the same spot in the sky, but they were close enough visually adjacent across nights, low in the same quadrant of the early morning sky. And that's when the photos started flooding in. Some telescopes caught K1 turning gold its dust, scattering the sun's light into radiant hues just before it fragmented. Other instruments were tracking 3I, Atlas, whose greenish coma remained steady, subtly outgassing CO2 and showing motion that didn't quite align with expectations. But few of the images were labeled precisely. A few posts included accurate celestial coordinates, and even fewer were accompanied by scientific caution. The public saw golden shattering. They heard Atlas, and the viral loop did the rest. We've seen this pattern before. In 2017, when Oumuamua became the first interstellar object detected, the mystery of its shape and spin pulled the scientific world into a whirlwind. But that object never visually dazzled. It stayed dim, distant. With 3I, Atlas, the conditions were different. It arrived during a moment when visual data photos, videos, telescope captures were being shared at unprecedented volume across multiple platforms, often without attribution or explanation. It's not that anyone was lying, it's that no one paused long enough to double-check. Even amateur astronomy networks, normally precise in their tagging, occasionally posted images of K, one labeled under the umbrella term Atlas Comet. And when algorithms prioritized what people clicked most, the gold comet took over. 3I, Atlas, the real interstellar visitor, was still there, still tracked, still discussed in academic circles, but to the wider public, it had fused with a golden imposter. So what does that teach us? It teaches us that timing, naming, and visual storytelling all matter. That even in science, especially in science, the story people believe often hinges not on the data, but on how the data is framed. It also teaches us humility, because even we, trained eyes, curious minds, careful observers, felt the tug of the illusion. We saw the beauty, and we assumed the name, and in doing so, we briefly replaced precision with awe. But now that the dust is clearing, literally, we can separate them. C. 2024. K1 was the golden one. The solar system was born, dusted, shattered. 3I. Atlas is something else entirely. Still whole, still active, and far more mysterious. We're watching them both now, but only one is rewriting the way we think about visitors from the stars. You know what's strange? A golden comet streaks through the sky, fracturing like a slow-motion firework, and the internet barely asks where it came from. We're all watching. We see the clips. We see the glow. We see the spiral debris like glitter unraveling from a silent tear in space. And we react. Whoa, is that 3I? Atlas? It's beautiful. It's breaking apart. Gold? But almost no one says, wait, is that even the right object? Why? Because the algorithm doesn't care. It doesn't know what comet is in the footage. It doesn't know which designation is correct. It doesn't fact-check spectral lines or check radial vectors or cross-reference perihelion distances with actual observation logs. It just knows one thing: which title gets clicked. Let's trace how the confusion happened, not from the telescope, but from the timeline. We now know the glowing object was C, 2024, K1. It had just passed closest to the Sun perihelion, and its dust coma, heated from the inside, scattered golden light into Earth's visual field. That was the real event. Meanwhile, 3I, Atlas, was still inbound, not glowing gold, not breaking apart, and not even on the same side of the sky. But someone took the clip of K, 1S gold tail, slapped the label 3I, Atlas on it, maybe by accident, maybe for effect, and posted it, and the system said, approved. Within hours, the visual went viral, and then the algorithm did what it does best. It began reinforcing the story. If someone typed 3I, Atlas Comet, they were shown the golden footage. If someone typed golden comet, they were shown the same thing. If someone uploaded a debunk or clarification, the algorithm quietly buried it. If someone clicked the wrong title once, that was all it took. Their feed began to fill with variations of the same illusion. This isn't a bug. This is how modern visibility works. You're not shown the most accurate content. You're shown the most clickable version of your last click. That's the loop. Engagement creates weight. Weight drags similar content to the surface. The surface becomes the illusion of consensus. And when consensus forms around a mistake, the mistake becomes real. Not in astrophysics. In the minds of millions. Here's what that looks like from the back end. Dozens of thumbnails showing the same golden arc. Dozens of titles. 3I. Atlas shattered after turning gold. First golden interstellar comet detected. NASA, stunned by 3I. Atlas fragmentation. Each one competes for microseconds of attention. Each one pushes slightly harder on the emotional pedal. Awe, urgency, mystery. None of them pause to ask, is this even the right object? That question isn't rewarded. Skepticism slows the loop. Doubt breaks the chain. Clarification gets fewer likes, and fewer likes mean a lower ranking. And lower ranking means invisibility. So the system filters it out. Let's put it plainly. The algorithm isn't evil. It's not conspiring to confuse us. It's just not human. It optimizes for interaction, not truth. Emotion, not clarity. Virality, not verification. And we, the viewers, the believers, the sharers, are not malicious either. We just don't realize how much control we've surrendered to the system's reflexes. What does this mean for science? For the public understanding of real cosmic events, it means that even with the most advanced telescopes on Earth, even with peer-reviewed data, even with clear designations and IAU protocols, one miscaptioned clip can overwrite weeks of actual astronomy, because the algorithm doesn't wait for data. It runs on speed, not accuracy. And if the story is beautiful enough, it doesn't matter whether it's true. You might wonder, why didn't the platforms correct it? Why didn't they flag the wrong video? Why didn't they prioritize the right comet? And here is the hard answer. There's no economic incentive to slow it down. There's no system-level reward for nuance. Subtlety doesn't go viral. Correction doesn't trend. The truth often arrives quietly, too late, too careful, too long. By the time scientific voices publish clarifications, by the time official accounts issue corrected visuals, by the time observatories confirm the object's identity, the public already knows what it saw, not because it was told by science, because it was shown by the algorithm. This is the architecture of illusion. It doesn't lie, it just amplifies what people already want to believe before the facts are even in. And that brings us back to 3I, Atlas, an interstellar visitor, a hyperbolic traveler, a rare, extraordinary object that does not glow gold, that has not shattered, that has not sprayed debris into space. But that's not what people saw first, and in the age of reflexive media, first impressions are not just sticky, they're structural. Once the loop forms, click, confirm, repeat, the illusion hardens. Like frost on a lens, like gold that never was. Let us be honest about the system we've built. A comet shattered, but not the one we thought. And a truth was buried, but not by malice, by mechanics. And now, we're left with a strange situation. The most viral story about an interstellar object in 2025. It's not about an interstellar object at all. It's about the kind of mirror we've built. One that shows us not the sky as it is, but the sky as we've been trained to feel it. Because the algorithm doesn't care. It reflects what we respond to, not what exists. And if that doesn't unsettle you, look again. We've all done it. You see something once, just a glance, and something inside clicks. A visual, a sentence, a color that doesn't belong. Your brain doesn't ask for credentials. It doesn't demand a second opinion. It makes a judgment call, and you move on, believing it. That's what happened to millions of people watching the gold-glowing comet fracturing video. No one paused. No one checked the naming designation. Why would they? The voice said, 3I, Atlas. The caption agreed. The visuals matched the myth, and the myth made sense. But this isn't a story about how people got fooled. It's about how belief happens. You're not irrational. You're efficient. Your brain evolved to find patterns fast and fill in the blanks faster. That's not a flaw. It's the foundation of human intelligence. We survive because we see structure, even in noise. But sometimes, the noise gets too good at pretending. Let's break it down. When the video of the golden comet began circulating, it hit every switch our minds are wired to trust. It had motion, so it felt real. It had a transformation, so it felt important. It had a dramatic payoff, so it felt worth remembering. And it had a voice calm, assured, certain. These are cues your nervous system tags as credible. They bypass skepticism. They skip the audit. This is not about low intelligence. It's about high cognitive efficiency. The science behind this is known as cognitive fluency. The easier something is to process, the more likely we are to believe it. Smooth narration, high-resolution visuals, and confident delivery don't just entertain, they reduce friction. And reduced friction feels like the truth. Now, add another layer. Truth fatigue. In an age of 24/7 alerts, viral clips, fragmented headlines, and AI-generated voices, our cognitive defenses are overstimulated. We don't disbelieve out of laziness. We accept because we're exhausted. Every correction feels like homework. Every retraction feels like betrayal. Every fact-check demands a toolset most of us don't carry on instinct. And when the visual matches the emotion we expect, we don't look further. We feel satisfied. So when 3I, Atlas was falsely linked to that viral golden burst, most people didn't resist. They embraced. Not because they were gullible, but because the illusion was beautifully made. It met them where they were, tired, curious, and quietly longing for a moment of cosmic wonder. Let's talk about that last part, the longing. Space doesn't just fascinate us because it's big. It fascinates because it's unedited. Unlike social media, space doesn't posture. Unlike politics, space doesn't spin. It's one of the few places left that feels honest because it doesn't care if we're watching. So when a story arrives saying, "Look, something unrepeatable just happened," we lean in. We want it to be true, because if it is, it means that somewhere, far beyond the noise of Earth, something pure just unfolded. Something we didn't control. Something beautiful, and maybe, just maybe, meaningful. This is pattern recognition with emotional incentive. We believe the golden comet shattered because we wanted it to. It gave us awe, and awe doesn't like to be interrupted by technicalities like naming errors or camera attribution. But we should still ask, why didn't the doubt rise sooner? Part of the answer is something called anchoring bias. The first version of a story we hear becomes the benchmark. Even when later corrections arrive, we tend to adjust around the anchor, not replace it. That's why people still call C, 2024K, the golden interstellar comet even now. The correction didn't come with enough emotional force to dislodge the initial impression. And there's another subtle force at play, the illusory truth effect. When we hear or see something multiple times, especially in slightly different forms, it starts to feel more true. Repetition equals reliability in the subconscious. So every re-upload, every repost, every minor variation on the golden 3I, Atlas theme, didn't just spread the mistake, it reinforced it. This is how narratives harden into beliefs. And once belief sets in, correction becomes confrontation. People feel attacked, not informed. The myth becomes part of identity. And the real comet, the actual 3I, Atlas, with its green coma and interstellar CO2 ratios, sits in the background. Scientifically rich, emotionally abandoned, this isn't just about astronomy anymore. It's about the architecture of modern knowledge. When a telescope catches something strange and rare, the burden of proof used to rest on scientists. Now it rests on the editors of the first viral upload. If that first edit is wrong even slightly, millions of minds may never course correct. Not because they refuse to, but because they don't know they're supposed to. So here we are. We're watching an audience believe something beautiful and false, while the truth quietly whispers in spectroscopic data, in hyperbolic orbits, in lines of code that the public never reads. And yet, we understand. We understand why it happened. We're not pointing fingers. We're holding up a mirror, because we do it too. Every day, we accept images. We nod at captions. We fill in stories based on tone, not source. We follow feelings, not footnotes. And the more we learn about this mistake, the more we realize it wasn't a failure of intelligence. It was a testament to how well human perception works and how easily it can be nudged. You believed a story that made sense. We all did, and now we know better. But let's not shame that belief. Let's study it, because next time, when the sky gives us a real anomaly, an object that isn't just gold in color, but gold in mystery, in implication, in origin, we'll be ready to see it clearly. Not because we've become cynical, but because we've become attentive. That's the shift we're making now, from consumers of wonder to curators of it. And in doing so, we preserve something far more precious than virality. We preserve the integrity of awe itself. We thought we saw something mythical, a comet glowing gold. But in space, beauty is never just beauty. It's a side effect of physics. Let's take a step back together, not from the story, but from the light. When the video first went viral, the golden hue was the emotional anchor. That soft, burnished glow like a candle flame stretched across the void felt too deliberate to be random. It had to mean something. We instinctively equate gold with rarity, with warmth, with value. And here it was, something unearthly, something real and golden. The illusion wasn't just visual, it was psychological. But now we know that the object in the video wasn't 3i, Atlas. It was C, 2024 K1. And now, as we rewind and ask why that glow felt so convincing, science begins to whisper a different kind of story. The golden color wasn't painted on. It wasn't a post-production artifact. It was light, filtered, scattered, and shaped by dust. And in that dust, we find the truth. When a comet approaches the sun, the heat does more than melt ice. It liberates minerals. Subsurface pockets of volatile gases expand, crack the surface, and eject material into space: silicates, carbon, metal grains. This cloud forms what we call the coma, and trailing behind it, the dust tail. These aren't poetic terms. They're dynamic, measurable structures governed by sunlight and gravity. You've probably heard of Rayleigh scattering, the reason our sky is blue, but comet tails obey a richer spectrum of scattering laws. Dust doesn't just reflect light. It diffracts it, polarizes it, and splits it by size and composition. And that's where gold enters the picture. We've learned that when iron-rich silicates dominate the dust environment, and when the particle size is right around 0.1 to 1 micron, they scatter sunlight in a very specific way. In forward scattered geometries, like when a comet is near perihelion and we're viewing it near the sun's direction, those grains can shift the perceived color spectrum toward warmer wavelengths. They don't emit gold, they scatter it into our eyes. Imagine holding a fine mist of rust-colored dust in front of a flashlight. From the side, you might see white or gray, but look toward the source of light, through the mist, and suddenly the beam turns amber. That's forward scattering, and in space, where there's no atmosphere to blur or absorb, the effect sharpens. This is not a hypothesis. We have precedents. Comets like C 1996, B 2 Hyakutake, and C 2006, P 1 McNaught displayed similar golden glows during their perihelion passes, when solar heating activated deep mineral layers and released fine metallic particles. Observers at low solar elongation, when the comet is visually near the sun from Earth's perspective, reported that same striking gold tone, not because the nucleus changed, but because the angle and dust size created a light filter more dramatic than any camera edit. C. 2024, K1 did the same. At the time of the viral footage, the comet was skimming near the Sun in its orbit. Telescopes captured the dust coma backlit by intense solar radiation. Spectral data suggests that its dust was dominated by iron-magnesium silicates, specifically olivine-type compounds, that scatter sunlight in that warm, gold-shifted spectrum under certain angular conditions. But here's the subtle twist. The color wasn't constant. Different viewers reported gold, bronze, and even silver-white. Why? Because the scattering effect isn't just about what the comet emits, it's about where you are standing. That's the paradox of visual truth in astronomy. Two people can observe the same object and see different colors, not because their equipment is broken, but because light behaves differently from different perspectives. It's not deception, it's geometry. And geometry doesn't care about our expectations. This explains why some observers of 3I, Atlas, weeks later, were confused by its lack of gold. They were looking at a fundamentally different object, one with a high CO2 content, a green coma from diatomic carbon and CN radicals, and a dust profile that scattered light in cooler hues. But their minds had already locked onto the earlier imagery. They expected gold, they saw green, and confusion bloomed. This is the emotional weight of visual anchoring. When something golden captures your imagination, cooler truths feel colder than they are. We assign meaning to color instinctively. And gold, for better or worse, has long been the color of divinity, of anomaly, of signal. That symbolism isn't new. Ancient observers marked golden stars as omens. Alchemists searched for aurum not just in metal, but in light. Even today, we use gold to denote signal strength, rarity, and celebration. So when the comet turned gold just for a few days, just from certain angles, it didn't just reflect sunlight. It reflected longing. And longing is sticky. Let's revisit the physics, briefly. The dust tail of a comet is not a uniform stream. It's a layered structure. Larger grains lag behind the nucleus. Smaller grains accelerate faster under radiation pressure. Each size scatters light differently, and as the comet rotates, as jets pulse, as sunlight shifts, the overall appearance fluctuates minute to minute, hour to hour. During the K1 event, the shattering of its nucleus added complexity. Fragmentation releases fresh material. Dust jets activate. The coma densifies. All of these effects amplify scattering, especially in the forward vector. What that means for viewers is simple. In those days, K1 was positioned perfectly to cast a golden veil, not because it wanted to, but because physics allowed it. And physics doesn't care how poetic it looks. Let's pause there. We're not just explaining color, we're retraining the eye. Because in the coming years, other objects will approach the Sunday, other tails will light up. Some may be green, some may be silver. One might shimmer with hints of violet or copper. If we chase meaning from color alone, we'll fall into the same trap. So we learn, not to distrust our eyes, but to augment them with context, with data, with reflection. When we look back at the golden footage, we don't need to feel foolish. We saw something real. We just mislabeled the source. And in doing so, we learned something profound. Truth can shimmer. But it's up to us to trace the shimmer back to its cause, because in the end, color does not mean. It's a clue, and the cosmos is full of clues, waiting for us to see, not just with wonder, but with understanding. We've all seen it before, a comet soaring through space, glowing, trailing, disappearing. But what does it actually look like? When does one break apart? Not the viral drama, not the edited montage. We mean physically, mathematically. You're about to witness the moment when beauty collapses and science begins. Let's go back to C, 2024 K1, the real golden one. The comet that the internet confused with 3I, Atlas, didn't just glow, it fractured. And that fracture wasn't just a visual phenomenon, it was a structural failure, unfolding across hundreds of kilometers and millions of seconds. From Earth, we saw it as elegance, but inside the coma, the story was violent. What breaks a comet? Comets aren't solid rocks. They're loosely bound conglomerates of ice, dust, and organic material, what scientists call rubble piles, held together not by strength, but by cohesion. Think of them as cosmic meringues, delicate, porous, beautiful, and vulnerable. As C 2024 K1 approached perihelion, it entered a zone of increasing solar stress. The sun's radiation didn't just heat its surface, it penetrated subsurface layers, expanding gases trapped in ancient voids. And with that expansion came pressure. But pressure wasn't the only force at play. There's something poetic about tidal forces. They stretch, they pull, they whisper before they scream. When a comet nears a gravitational well like the sun, the difference in gravitational force between its near side and far side creates stress. For solid bodies, like planets or moons, that stress is usually negligible. But for a fragile, rotating nucleus, it's a death sentence. We believe C 2024 K1 underwent what's known as rotational breakup. Here is what that means. As jets of gas and dust escape from the surface, they act like thrusters. If they're asymmetrical, and they often are, they exert torque. That torque causes the nucleus to spin faster. And as spin increases, centrifugal force begins to act against gravity and cohesion. Eventually, the nucleus reaches a critical spin rate. The outer layers begin to separate. Cracks propagate inward, and then it happens. Fragmentation. To the naked eye, it might seem like a single flash, a puff of brightness. But with telescopes, we can see the real choreography. Multiple fragments emerge, sometimes a dozen, sometimes hundreds. Each fragment has its own velocity vector, slightly different from the main body. That means, over time, they drift apart. From Earth, we begin to see a bifurcated nucleus, or an elongated central region. The coma dims, but expands. The tail shifts, split by multiple dust trails tracing divergent paths. In the case of C 2024 K1, this wasn't just theory. Between August and October 2024, multiple observatories reported increasing asymmetry in the coma. Then, in mid-September, the Lowell Discovery Telescope captured high-resolution imagery showing at least 3 discrete nuclei within the main dust envelope. Follow-up observations confirmed divergent trajectories. The comet hadn't just brightened, it had fractured. Each fragment was now its own micro-world venting, sublimating, releasing dust. But that's not all. Fragmentation isn't always symmetrical. Often, one fragment dominates, retaining most of the mass, while others are smaller, irregular, chaotic. Some spin uncontrollably, others vanish within days. Some even refragment, creating a cascading chain reaction of breakups. The complexity of these events is staggering, and yet they're governed by relatively simple physics. Imagine a spinning watermelon thrown into a vacuum. As it heats, internal pressure builds. Cracks form, a sudden shift in spin, and pieces tear off, each with just enough momentum to chart a new path. That's a comet in distress, except it's 50 kilometers wide. And the vacuum is space. The most dramatic comet breakup on record was Comet Shoemaker Levy 9 inches, 1992, torn apart by Jupiter's gravity. But K1's case is different. It fragmented not because of a planet, but because of itself, its own instability, its own proximity to the Sunday. And that's what makes this awe-inspiring. C 2024 K1 didn't need to crash into anything. It simply couldn't hold together. As its internal vents opened, as solar radiation pounded it, as the nucleus spun faster, its own body became the enemy. That's the silent violence of fragmentation, the collapse of a structure under the weight of its own awakening. From Earth, we watched a beautiful tail stretch longer. We saw gold hues brighten, then fade. We thought it was still one thing, but it wasn't, and that illusion, that singular comet image, is where the misunderstanding with 3I, Atlas, began. Because in those days, the sky had 2 comets, but only one was falling apart. Only one was releasing fragments, detectable by a change in motion. Only one showed a coma growing asymmetrical with measurable divergence. Only one left behind a signature of crumbling cohesion, dust trails, sudden jets, velocity shifts. The other 3I, Atlas, remained smooth, solid, intact. That's the distinction that matters. And it's not just semantic, it's scientific. Because fragmentation has meaning, It affects how we model comet life cycles. It informs how we design intercept missions. It shapes how we estimate impact probabilities. And yes, it fuels how we interpret visual phenomena. If we think every comet that glows brightly is fragmenting, we overstate risk. If we ignore signs of fragmentation, we miss potential scientific goldmines. So, what did we really witness? Not just a golden glow, not just a dramatic sky event. We witnessed a body giving way to the forces it could no longer resist, a self-shattering sculpture, a fragile witness of solar evolution, a messenger from the deep, falling apart in slow motion, leaving trails not just of dust, but of data. That's what fragmentation looks like. And now that you know, you'll never mistake it for clickbait again, because the universe is more dramatic than our thumbnails, more complex than our captions, and far more beautiful than we often give it credit for. We didn't just see a comet break, we saw nature's choreography of collapse. We saw the headlines, we saw the thumbnails, we saw the gold. But when we turned our telescopes to the real interstellar visitor, what we saw was not gold at all. It was green. Not metaphorically, not poetically, literally optically, chemically green. And that single color told us more about this object than 1,000 viral edits ever could. Let's step into that light. You're looking at 3I, Atlas, not the one the internet dressed up in gold, but the actual interstellar object catalogued with a hyperbolic trajectory and inbound from beyond the sun's gravitational hold. And what makes it stand apart? Is that eerie, unmistakable, alien glow? It's not just a smudge. It's not just reflection. It's fluorescence, the physics of the green glow. When sunlight hits a comet, it doesn't just bounce off the surface. It penetrates, energizes, and reacts with the gases surrounding the nucleus. These gases are created as frozen material on the comet sublimates, that is, turns directly from ice to gas when the object gets close enough to the sunday. And among those gases, two culprits stand out: diatomic carbon, C2, cyanogen, Cn. Both are short-lived molecules that exist in the coma, the luminous cloud of gas surrounding the comet's core. When these molecules are excited by ultraviolet light from the sun, they emit visible light as they return to a lower energy state. For C2 and Cn, that light is green, specifically in the range of 518 to 552 nanometers. That's why 3I, Atlas, glowed green. Not because of dust, not because of minerals, because of gas, chemistry. Ionization. This isn't unique to 3I. Atlas many comets exhibit green comas. But the brilliance and consistency of the green signature here stood out, especially compared to C 2024 K1, whose gold was from dust-scattering light reflecting off iron-rich grains and other solar-irradiated materials. But 3I, Atlas, had no such signature. Instead, it presented a remarkably stable, symmetric coma, dominated by gas emissions without the broad-spectrum reflection you'd expect from high dust content. That's not an aesthetic difference. It's a chemical fingerprint, the evidence from spectroscopy. Multiple observatories confirmed this green glow through spectral analysis, the process of separating light into its constituent wavelengths to identify the materials responsible. In July and August 2025, data from the Las Cumbres Observatory and follow-ups from amateur astronomers using narrowband filters showed strong emission lines in the C2 swan bands, around 516-520 nanometers. Even more importantly, no corresponding yellow or gold reflection peaks were detected. That confirmed it. The coma was gas-dominated. The primary emission was diatomic carbon. The coloration was intrinsic, not camera artifact, not overexposure, not a trick of the lens. This was the true appearance of 3I, Atlas, and it tells us something more profound than color theory. It tells us about the origin. Why green means interstellar. Most comets in our solar system, especially short-period ones, lose their more volatile compounds over time. After multiple passes near the sun, their outer layers have been baked clean. What remains is dust, rock, and slower to sublimate ices. But 3I, Atlas, is different. It hasn't been here before. It hasn't looped past the sunday. It's not part of our planetary system. Its hyperbolic excess velocity and eccentricity greater than 1 confirmed by JPL horizons prove it's on a one-time journey through our system, possibly from another star. That means it still contains primordial ices and gases, materials unchanged since the time of its formation. and that includes large reserves of C2 and CN compounds that break down easily under prolonged solar exposure. So when you see green on a comet like this, you're seeing freshness, unprocessed chemistry. It's like reading the ingredients label on the universe's original recipe. And that matters, the structure behind the color. Look deeper, and you'll see more than a glow. You'll see structure. 3I, Atlas, exhibits what's called a well-formed ion tail, a narrow, straight line extending away from the sunday. This tail is driven by solar wind pushing charged particles away from the nucleus. Unlike dust tails, which are curved and gold-toned due to reflection, ion tails are blue or green, straight, and fade more quickly. Why? Because the ions are lighter, they accelerate faster, and they react more immediately to solar wind vectors. So when 3I, Atlas, developed its green glow, it also displayed a tightly collimated ion tail, one that could be measured, modeled, and verified. That tail wasn't golden, it wasn't wide or turbulent, it was cold, clean, and scientific, and it confirmed everything the spectrum was already telling us, misunderstanding the image. So how did we go from this green, symmetrical, scientifically fascinating object, thinking it was a shattering gold fireball? Simple. The images people were sharing weren't of 3I, Atlas, at all. They were of C, 2024 K1, and that confusion happened because of timing. During the early weeks of September, both comets were active, both were captured by amateur astronomers, both had bright comas and tails, but only K1 was dust-rich, and only it glowed gold and fragmented. Yet the name Atlas, which sounds dramatic and cosmic, was already circulating. So when people saw a comet that looked epic, they attached that name to it, and the illusion was born. But the real interstellar visitor, the one carrying secrets from outside the solar system, never fractured, never flashed gold, never broke apart. It stayed stable, it stayed green, it stayed real. What the green tells us now, in a way, it's poetic. The object that got all the attention was dramatic, bright, and photogenic. The one that passed us silently, intact, with a scientific payload of interstellar chemistry. That one glowed softly in green and went largely ignored. But not by us. We watched. We recorded. We compared spectra, ran Doppler checks, measured OH emissions at 18 centimeters, and tracked jet stability. And we saw something extraordinary not in the gold, but in the green. Green meant interstellar, pristine, intact, scientifically rare. And in that glow, we weren't just looking at a comet. We were looking back in time, to another system, another star, another beginning. So the next time someone shows you a gold comet and tells you it's shattered, ask for the spectrum. Ask for the orbital data. Ask what color it was really. Because in science, the truth isn't always the loudest. Sometimes it's just the right color. We watched 3I, Atlas glow green. And in that glow, we saw something deeper than spectacle. We saw the quiet truth of the universe unfolding in wavelengths. 2 comets. One broke apart in plain sight. The other didn't even crack. You've probably seen the dramatic images by now. C, 2024 K1, golden and luminous, its nucleus shedding fragments like embers from a fire. It looked chaotic. It looked cinematic. And then there was 3I, Atlas, green, quiet, still intact. Despite the headlines, despite the confusion, despite a dozen influencers claiming otherwise, 3I, Atlas did not shatter. It remained whole, consistent, and remarkably stable, even as it passed near the sun's intense heat. That raises a simple but profound question. Why did one comet break, and the other didn't? Let's begin with what we know. Not all comets are built the same. The structure of a comet is a product of both its composition and formation history. Most solar system comets, especially ones on short-period orbits, have been exposed to solar radiation for millennia. Each pass near the sun strips away a little more of their volatile materials. Their surfaces become crusted, compacted, and baked. But 3I, Atlas, it's not from here. Its hyperbolic orbit, confirmed by JPL horizons, places its eccentricity well above 1. That tells us it's interstellar, and this is its first and likely only pass through our solar system. That difference changes everything. C, 2024. K1 has made at least one full orbit, and its current perihelion brought it far closer to the Sun than 3I, Atlas ever did. K1 reached roughly 0.8 AU, a harsh, blistering environment. 3I, Atlas, in contrast, stayed well beyond 1.4 AU during its perihelion. Close enough for solar heating? Yes, but not the kind of searing intensity that melts surfaces and rips nuclei apart. So we begin to see a pattern. Distance, composition, structure, they all played a role in who survived and who fragmented. Sublimation pressure, the invisible sculptor. As a comet nears the Sun, its surface begins to warm, but it doesn't melt like an ice cube on a summer sidewalk, it sublimates. That means it's ice, primarily water, H2O, carbon dioxide, CO2, and carbon monoxide, CO, that turns directly into gas, creating internal pockets of pressure beneath the crust. If that pressure builds too fast or the surface is uneven, the structure can crack. Sometimes it crumbles. That's what happened to C. 2024 K1. Spectroscopic analysis from ground-based telescopes revealed a relatively high H2O content in K1's coma. Strong OH bands and water vapor lines suggested water ice was one of its dominant volatile drivers. Water ice sublimates rapidly at to 0.8 AU, and if the surrounding matrix, dust, rock, or loosely packed material can't vent it efficiently, pressure builds. Eventually, that pressure exceeds the structural limits of the nucleus, and it breaks. In contrast, 3I Atlas showed unusually high CO2 to H2O ratios, estimated in some models as high as 8:1, based on OH, 18 cm line weakness, and infrared signatures. CO2 sublimates more gradually and at a greater distance from the Sunday. It produces activity, yes, but not the kind that explodes. This meant 3I Atlas could sustain outgassing without destabilizing its core. Its jets formed, its coma expanded, but it didn't rupture, it vented. Integrity. From the start, another overlooked factor, porosity. Solar system comets tend to have layers, materials compacted from repeated heating and cooling cycles. These layers can trap volatiles beneath denser crusts, forming pressure cookers. But interstellar comets, like 3I, Atlas, are likely more porous, built from loosely held aggregates of ice and dust that have never experienced close stellar passes. This porosity gives gas an escape route. Rather than building pressure in sealed chambers, volatiles can diffuse through the matrix and escape gradually. Think of it like a sponge versus a sealed plastic bottle. When you squeeze the sponge, water seeps out. When you squeeze the bottle, it bursts. 3I. Atlas was a sponge. K1 was a bottle. Rotation matters. 2 spin plays a role in whether a comet survives. Rapid rotation can create centrifugal stress, especially in elongated or irregular nuclei. If a nucleus spins too fast, it can tear itself apart like a dumbbell thrown into a spin. Observations of C. 2024 K1 revealed hints of asymmetric outgassing, suggesting one side was venting more heavily than the other. This imbalance could have introduced torque, spinning the nucleus up over time. And if that spin rate crosses a critical threshold based on size, mass distribution, and tensile strength, it can trigger rotational fragmentation. 3I Atlas, on the other hand, showed no such instability. Its light curve remained stable, no spin-up, no precision, just a slow, steady rotation. That kind of balance matters when survival is on the line. Mass, shape, and thermal load don't forget. Fragmentation also depends on how mass and geometry distribute thermal stress. A small, irregular comet absorbs heat unevenly. One lobe may sublimate faster, weaken, and break off. A larger, more spherical body spreads thermal load more evenly. Initial observations estimate that 3I Atlas is relatively compact and symmetrical based on coma symmetry, consistent jet orientation, and brightness falloff. C. 2024 K1. Meanwhile, displayed early signs of nucleus elongation, and some models suggested a bilobed or peanut-like shape, a known precursor to splitting. That geometry, combined with a steeper solar angle and higher internal pressure, made it vulnerable. The result was inevitable. Fragmentation isn't always catastrophic. Sometimes, A comet breaks and continues. K1 is still visible. It still emits gas, but it's no longer whole. And fragmentation isn't always a death sentence. It can expose fresh material, create mini-comets, or alter orbital paths. But it's still a rupture, a release. 3I. Atlas never needed that. Its structure held, its chemistry supported stability. Its path kept it away from the worst of the solar onslaught. And so, while one comet dramatized its ending in golden shards, the other whispered its passage in silence. What stability means. When we say 3I, Atlas stayed whole, we don't just mean physically, we mean scientifically. Its stability means we can model its interior, we can track its jets, we can test theories about interstellar material because nothing collapsed mid-observation. It gave us a clean case, a pristine object traveling on a hyperbolic path, unbroken, unbent, untouched by orbital recycling. And that's rare. That's valuable. That's a story worth listening to even if it doesn't sparkle. We watched one comet fracture and another glide. We heard the crowd cheer for gold and ignored the quiet green. But the science didn't. The science saw strength in silence. It saw survival not as boring, but as a beacon. And now, we know more. About structure, about chemistry, about what it takes to last. 3I, Atlas stayed whole. Not because it was lucky, because it was different. And in that difference, we find everything we needed to ask better questions about what comes next. It was beautiful. The gold shimmer, the drifting fragments, the illusion of a cosmic unraveling, captured in perfect resolution. You probably saw it in your feed, maybe shared it, maybe paused, jaw slack, fingers hovering just long enough to make the algorithm smile. It looked like the truth. It looked like 3I, Atlas. But it wasn't. We all got swept into it. The glow, the shatter, the claims of alien origin, of strange chemistry, of something never seen before. And behind those claims, thumbnails screaming in all caps, arrows pointing nowhere, voices whispering, "What are they hiding?" We wanted to wonder. We got a polished fiction instead. The lie wasn't just in the pixels, it was in the framing, the timing, the assumption. 2 comets are active at once, one green, one gold, one stable, one breaking. But we only had room for one story. And the louder, shinier one won. That's how false narratives root themselves. Not in malice, but in momentum. You saw a golden tail. You were told it was interstellar. Your brain did the math before the data ever arrived. That's not your fault. It's how we're wired. When R outpaces accuracy, we are pattern makers. We stitch cause to effect, image to meaning. We crave coherence. We prefer a single answer that feels right over 3 that are. So when C, 2024 K1 began to glow beautifully, suddenly, dramatically, and someone mislabeled it as 3I, Atlas, the fiction didn't feel wrong. It felt perfect. An alien visitor entering our system, shedding its shell in golden grief. A comet turning to light as it said goodbye. It was cinematic. It was poetic. It just wasn't real. But by the time correction came, data sets, designations, spectral comparisons, the belief had calcified. It had become content. Truth wasn't loud enough. We issued updates, posted clarifications. Actually, that's C, 2024 K1, not 3I, Atlas. Actually, 3I, Atlas, has a green coma, not a gold one. Actually, it didn't break apart. But truth moves slowly. Correction is quiet. And the algorithm doesn't reward nuance. In the attention economy, speed beats substance. Emotion outperforms evidence. And we end up chasing phantoms in the light. Spectacle versus substance C, 2024 K1 gave us a show. It shattered. It sparked. It painted the sky with the drama of destruction. And yes, it was real. It was worth it. But 3I, Atlas, gave us something rarer. Not a spectacle, but a calibration point, a data set, a survivor. It didn't burn. It didn't flash. But it told us about its origin, its chemistry, its integrity. And we nearly ignored it because it didn't look like the movie in our heads. This is the danger. When beauty hijacks attention and attention rewrites truth, science becomes secondary. The thing that mattered, the interstellar visitor, was demoted to a side note because it didn't sparkle, narrative distortion. What started as an honest mistake, confusing two comets, became something else. A cascade of viral videos, recycled scripts, misleading titles, and eventually, deliberate framing. The lie evolved, it optimized, it mutated for clicks. Some called 3I, Atlas, the golden alien comet. Some claimed it was sending signals. Others said its tail pointed toward Earth on purpose. All of it rooted in a beautiful image of the wrong object. That's how narratives distort. They don't just add noise, they displace the signal. They turn a clean scientific opportunity into a hall of mirrors. We helped it happen. We don't say this with judgment. We say it with awareness. We clicked, we speculated, we amplified. Even well-meaning posts correcting the record still drove traffic to the original mistake. And that taught the system a lesson. Lie first, correct later, profit regardless. This isn't a condemnation. It's a reflection. We all want to believe in wonder. But wonder should not come at the cost of accuracy. When wonder and truth align, because here is the real tragedy, we didn't need the lie. The truth was already amazing. 3I, Atlas is interstellar. Its chemistry is strange. Its motion is puzzling. Its survival is a question. It's glowing green because of diatomic carbon and CN. It's emitting jets with a CO2 to a 2O ratio, unlike anything we've seen. It accelerated without braking. That's not boring, that's breathtaking. But it didn't have a golden tail, so we looked away. The cost of misdirection. Misinformation doesn't just cloud understanding, it wastes opportunity. Astronomers had to spend precious time clarifying. Public focus was split. Telescope time, attention, and trust were all diluted. And for what? An extra million views? A thumbnail that lied louder? If we want the public to care about science, we have to show them how to care responsibly. Because if every true thing is ignored for the shinier lie, we train ourselves out of truth. What we could have done, we could have celebrated both. The Golden Breakup of C, 2024 K1, is a dynamic solar system drama. The stable green of 3I, Atlas, is a once-in-history visitor from another star. We didn't need to choose, but the feed made us choose, and so we lost the plot. Not because we're careless, but because the architecture of attention isn't built for complexity. The quiet thing that mattered, 3I, Atlas, didn't shatter, it didn't glow gold, but it did something rarer. It gave us clean data, a direct look into material from outside the solar system, a silence that held up under scrutiny. It was never the golden comet. It was something better. It was real. In the end, beauty isn't the problem. Lies wrapped in beauty are. When stories overwrite science, we lose both. Let's not do that again. Let's make room for the spectacle and the substance. Let's teach the feed to reward accuracy, not just awe. Let's let truth be beautiful, even when it's green, quiet, and whole. While the world was chasing gold dust, something far rarer slipped almost unnoticed through our hands. It didn't sparkle, it didn't shatter, it didn't scream for attention, but it mattered more than anyone realized. We're talking about 3I, Atlas, the real one, the quiet one, the one that didn't explode in front of a viral camera, but instead whispered something profound from the far edge of the solar system. You almost missed it. We almost missed it, because our eyes were on a drama that never belonged to it in the first place. Beneath the noise, a signal. Imagine this. An object older than Earth, formed in a cradle of dust around another star, traveling for eons through the interstellar void, untouched, unchanged, carrying within it a frozen chemistry from another sun. That's what 3I, Atlas, is. A visitor, an emissary, not of technology or civilization, but of memory. While we were distracted by the wrong color, the wrong tail, the wrong comet, this one was telling us its truth. In its spectra, in its silence, in its refusal to behave like anything we'd seen. Chemistry from the void we've seen comets before. Hundreds. We know what water vapor looks like, what dust tails do, what sublimation curves should plot. But 3I, Atlas, said, not this time. The first red flag was the ratio CO2 to H2O. In a typical comet, especially those from our own Oort cloud, water dominates. It evaporates closer to the sun, forming the familiar coma and jets. But 3I, Atlas, showed 8 parts CO2 for every part of water. That's not just unusual. It suggests a birthplace rich in carbon dioxide, colder, perhaps darker than our own protoplanetary disk ever was. And it means this object was forged under different rules. It's not just traveling through our solar system. It's revealing where else stars are born. Organic clues in green light, you've seen the glow. Not gold, but green. That green isn't just visual candy, it's chemical speech. 3I, Atlas's coma, is rich in diatomic carbon, C2, and cyanide, Cn, molecules that fluoresce under sunlight, giving that ghostly green hue. But more than color, they hint at organic complexity. These aren't just simple gases. They're fragments of life's building blocks. Not life itself, but the alphabet. If we're searching for the universal chemistry that could seed habitability, we don't need to look to science fiction. We need to look right here, at 3I, Atlas, at how these molecules behave when preserved for billions of years and then reawakened by sunlight. This isn't speculation. It's spectroscopy, the shape of interstellar memory. The light curve of 3I, Atlas, how its brightness varied as it spun, told us something else. This object is stable. No chaotic tumbling, no signs of cracking, just a slow, measured rotation around a locked axis. It survived its first approach to the Sunday. It didn't flinch, it didn't flake apart. And that's stunning, because most comets, especially long-period ones, crack under pressure. Their interiors are porous, fragile, and inconsistent. But 3I, Atlas, it held. Which raises the question, what is it made of? Is this structural integrity a sign of different chemistry, of a different formation temperature, of a different origin story altogether? We don't know yet, but it's a question worth asking, one we nearly forgot to ask. A timeline we can't afford to lose. We had a window. A few months, that's all we ever get with interstellar visitors. They come in fast, they leave faster, and every night matters. While we were replaying YouTube videos of gold breaking off into the black, some telescopes were actually locked onto the right target. Meerkat, ALMA, Vera Rubin, JWST. They caught data, but public attention lagged. And here's the danger. Without public interest, funding falters, priorities shift, and the next visitor might pass without anyone watching. The silence of good data. We talk a lot about signals, radio bursts, flashes, jets, but sometimes the most important data isn't loud. It's stable. A green glow, a consistent coma, a non-gravitational acceleration that matches no thermal model. 3I, Atlas, didn't just give us something to gawk at, it gave us something to model, to study, to base the next decade of cometary physics on. It's a baseline, a fingerprint from beyond, and we almost missed it because it didn't glitter. The real gold iron particles can scatter light and produce golden tails. That's what happened with C. 2024 K1. But 3I, Atlas carried something more valuable. Carbon chemistry that predates our Sunday spectral lines that don't quite match anything in our databases. A shape that resisted destruction. A spin that hints at engineered balance not from technology, but from natural perfection. This is gold of a different kind. Not visual, but informational. And in science, that's what matters most. Regret, then reawakening. We let the wrong story go viral. We elevated spectacle over significance. But now, maybe, we wake up. Maybe we remember that the universe isn't obligated to impress us with fireworks. Sometimes it just shows up with quiet truth. And if we're paying attention, if we learn to look beyond the thumbnails and trending hashtags, we might catch the next one. In time, with clarity, with reverence. What you can still do, it's not over. 3I, Atlas, is still inbound. We still have eyes on it. The December window is approaching, and this time, you know better. Don't look for gold. Look for green. Don't expect a climax. Expect subtlety. Share the data, not the drama. Teach others what to look for, because if we can shift even a fraction of public attention toward the right object, the right question, the right silence, we might earn another shot, understanding, at truth. We almost missed the real story. Let's not do it again. We live in an age where speed wins, where being first often matters more than being right. But science doesn't play that game. It can't. Because when the stakes are cosmic, when the questions concern the fabric of space, the origin of matter, or visitors from other stars, certainty is sacred. And that certainty doesn't come in a viral video, it comes from vigilance. Truth has a tempo. Let's say it plainly. Science is slow. That's not a weakness, it's the design. Because every claim must survive. Fire peer review, reanalysis, replication. Every data point must stand, not just in one paper, but across time, across teams, across tools. When we saw what looked like a comet breaking apart in golden shards, the impulse was immediate. Share it. Name it. Frame it. But that's not how science moves. We ask, did the light curve support that? Was the position confirmed? Were the instruments calibrated? You can't fast-forward rigor. Skepticism isn't cynicism. It's tempting to see skepticism as resistance, as reluctance to believe. But that's a misunderstanding. Skepticism isn't the opposite of belief, it's the pathway to it. It's the reason we recheck telescope logs. Why do we cross-match with archival frames? Why we ask, are you sure this is 3I Atlas and not C 2024 K1? And when the answer is no, we weren't sure, we don't cancel the scientist. We don't ridicule the public. We correct the record. We say, here is what we thought. Here is what we know now. Because science doesn't chase applause. It earns clarity. Retraction is a virtue. In viral culture, admitting you were wrong is seen as weakness. In science, it's a badge of honor. Every retracted paper is a system working. Every corrected plot is a mark of integrity. You don't want a field where no one ever changes their mind. You want one where truth evolves, not based on belief, but based on new light. The misidentification of 3I, Atlas, wasn't a scandal. It was a signal, a reminder that when multiple comets appear simultaneously, when media loops images without context, and when thumbnails override titles, confusion is inevitable. So the correction isn't shameful. It's a celebration of vigilance. Observational rigor. What it takes behind every correction is a wall of effort. You don't just know which object is which. You analyze ephemerides, track RA, DEC positions across nights, compare gas emission lines, check angular velocities, filter color indexes from stacked CCD frames, validate point spread functions, cross-reference object designations with IAU records. That's not overkill. That's what it takes to avoid mistakes. And when someone does it, even after the media has moved on, they're not nitpicking. They're preserving the chain of custody for truth. Why it matters? Let's be clear. If we had accepted the viral story as fact, if no one had reanalyzed the data, we would have recorded that an interstellar comet turned gold and shattered. That record would go into the databases, into textbooks, into future models, and it would be wrong. That's how misinformation calcifies, not through malice, but through momentum. So when a few astronomers and amateurs spoke up, when they traced the observations back and realized it was K1, not 3I, that glowed gold, they didn't spoil the story. They saved the signal, the community that guards the gate. This isn't just about institutions. It's about people. People who stay up all night checking orbital simulations, write careful forum posts on cloudy nights, double-check JPL entries and note inconsistencies, post annotated images comparing the same region across weeks. That's the scientific community at its best. Not credentialed, not paid, not seeking credit, just guardians of precision. You might never hear their names, but the truth owes them everything. You are part of this. Yes, you. Every time you pause before reposting, every time you read the caption and the comments, every time you ask, where did this data come from? You participate in vigilance. Science is not a spectator sport. It's a collective responsibility. And the moment we forget that the moment we favor aesthetics over evidence is the moment we trade knowledge for comfort. We can do better. From spectacle to stewardship, we're not here to dazzle, we're here to understand. That means sometimes letting go of a beautiful story, of a golden glow, of a shattered comet that never shattered, and embracing the quieter truth. A green interstellar traveler, whole, stable, and ancient, whispering its message through chemistry. Not spectacle. It's less shareable, less cinematic, but it's real. And in the long arc of history, real is what lasts. We stayed vigilant, and because we did, we saw clearly. You can too. A golden streak appeared across our screens, glowing, crumbling, viral. It had a name, 3I, Atlas. It had a story, interstellar, rare, breaking apart before our eyes. Except it didn't. Not that comet, not that way, not that truth. And yet the world believed it, not because we were foolish, but because we're human. This isn't a story about telescopes. It's a story about how we see. The speed of wanting to know. We don't just seek knowledge, we seek certainty, and we want it fast. In a world of scrolls and swipes, stillness looks like ignorance, hesitation feels like failure. So when something extraordinary appears, something glowing gold, framed by the void, our minds reach out to make meaning, quickly, confidently. That's the interstellar comet, we think. That's what it looks like when it dies. I knew it would be special. The image becomes memory. The story becomes fact, but in that rush, we bypass something essential. Not true, but the space truth needs. Algorithms don't read footnotes. Let's be honest, most people didn't follow the trajectory, didn't check the designations, didn't notice that the golden one was C, 2024 K1, and the green one was 3I, Atlas. They saw a thumbnail, read a headline, watched 15 seconds of awe, and that was enough. Not because people are careless, but because systems are built to compress. In the world of attention economies, nuance is a liability. Ambiguity doesn't trend. Footnotes don't go viral. So even if a video says, this may not be 3I, Atlas somewhere in the middle, the damage is done. The image is out. The association is locked. The algorithm doesn't care about context. It cares about clicks. And in that ecosystem, mistakes don't correct, they amplify. The illusion of understanding. Let's imagine you're watching from your phone, you're between emails, you're tired, you see a flash of gold, a voice says interstellar, the visuals say shattering, and you feel it wonder. But it's fast, it's framed, it's partial, and what you've received isn't knowledge. It's the illusion of knowledge. This isn't just about one comet, it's about a pattern. We're increasingly surrounded by compressed versions of truth, not lies, but shortcuts, abstractions, visuals without lineage, claims without caveats, certainty without scrutiny, and over time, it wears us down. Misinformation fatigue. When everything is suspect, when every image could be mislabeled, when every headline feels like bait, something breaks. We stop asking, we stop checking, we stop caring. That's misinformation fatigue. It doesn't look like panic. It looks like resignation. And it's dangerous, because the antidote to misinformation isn't more information. It's attention. But attention is finite. If we spend it all chasing the newest glow, we have none left for the quiet truths still forming in the background. Like the real 3I, Atlas, green, whole, whispering its chemistry into the void, ignored because it wasn't gold. The ethics of the feed. Let's pause. No one set out to deceive. The people who posted the videos, who shared the images, who made the thumbnails, they were excited. They were moved. But the platform didn't know that. It didn't wait to verify. It just rewarded behavior. More clicks, more reach, more engagement, more replication. And when something spreads like that fast, emotional, spectacular, it becomes hard to undo. Not because truth can't be found, but because the system doesn't reward finding it. It rewards confirming what people already want to believe. That's not a failure of content. That's a failure of design. We're not just consumers. Every time we click, comment, or share, we're not just consuming. We're training the system. We teach it what to amplify, what to suppress, what to echo. So the question isn't just what's true. It's what truths are we making easier to see, and which ones are we burying beneath noise? This wasn't about comets. This was about mirrors. 2 comets passed near the Sunday, one shattered, one didn't. But what broke was not just the rock. What was shattered was a layer of assumption about how we know things. And in that dust cloud, something valuable appeared. A glimpse of ourselves, our hunger for meaning, our impatience with ambiguity, our vulnerability to aesthetics, our trust in machinery we don't fully understand. The golden light reflected more than particles. It reflected us. and that reflection wasn't always flattering. But there's hope. We're not powerless. We can pause, we can ask, we can share with caveats. We can click less on spectacle, more on substance. And when we do that, we change the system. We train the algorithms. We elevate rigor. We slow the spread of error. We create a space where science can breathe, and that matters. Because the universe doesn't owe us clarity. We have to earn it. With patience, with humility, with each other. We watched the wrong comet, but that mistake became a window. Now, the real question is, what will we do with what we saw? We've spent hours untangling the confusion. Now we return to what was never confused, to the one who never shattered, to the one who never tried to glow gold. 3I, Atlas, not a headline, not a thumbnail, not a case of mistaken identity, just itself. And that, on its own terms, is astonishing. A path not from here, every rock we know obeys the Sunday. It arcs around, falls inward, swings back out, obeys the long rhythm of our stars, gravity. But 3I, Atlas, came from elsewhere. Its trajectory doesn't loop, it escapes. Its motion isn't curved, it's carved by memory. From the moment we first saw it, 3I, Atlas, was already outbound, already past perihelion, already on its way to never return. That's what interstellar means. It isn't just a label. It's a kind of loneliness, a kind of clarity. It means this object was born around another star. It means every molecule, every isotope inside it holds stories older than Earth. It means we got one shot, one slingshot glimpse at chemistry from another system. And we almost missed it. The silence of the data. This comet didn't roar. It whispered. While cameras hunted gold and fragmentation, 3I, Atlas, gave us something quieter. Green. 2. Non-gravitational motion. No explosive break. No dramatic tail. Just a coma that pulsed with diatomic carbon. A spectral fingerprint of ionized gases whispering, I was made elsewhere. Radio arrays heard the OH line, the echo of water. A 1,667 megahertzes whisper across space. Telescopes tracked its slow spin. They mapped its orientation. They calculated its outgassing vectors. What they saw wasn't random. It was precise, engineered by thermal geometry and ancient memory. This was not chaos. This was choreography. The chemistry of elsewhere. Let's break that down. 3I. Atlas isn't just a rock flying fast. It's a relic of a different star's nursery. Its high CO2 to H2O ratio is unusual, higher than we've seen in most solar system comets. That alone suggests it formed in a colder, more volatile, rich environment. Its green hue comes from diatomic carbon, C2, and cyanogen, Cn, gases that fluoresce under solar UV, but which are fragile, unstable, and easily destroyed near stars. And yet, they're still there, preserved. That means this thing hasn't been around stars much. It's pristine, untouched. It didn't come from the Oort cloud. It came from deep interstellar space, possibly a planetary system disrupted by a passing star, possibly a chaotic birth cloud tossed wide into the void. But wherever it came from, it carried secrets. We just had to know where to look. Motion that doesn't obey. One of the strangest things about 3I, Atlas isn't its chemistry. It's its motion. In the data, there's a measurable deviation from what gravity alone predicts. It's subtle, but persistent. Some called it non-gravitational acceleration. That's not magic. It's physics. When gases escape a comet's surface, they push back like jets. This creates tiny thrusts, nudging the comet off its purely gravitational path. But with 3I, Atlas, something's odd. The outgassing is happening, without a visible tail, without fragmentation, without a rotating spray of debris. Just a soft green coma, and motion. It raises questions. Is the vent geometry focused? Are the jets collimated? Could this be natural engineering or something else? We don't leap to conclusions, but we do ask questions, because that's what science does. When 3I, Atlas, emerged from behind the sun in November 2025, astronomers were braced for silence, for broken pieces, for dust. Instead, they found it intact, still glowing, still moving. That survival was a revelation. Perihelion closest approach to the Sun should have torn it apart. The heat, the spin, the tidal stress. But it endured, and that endurance was data. It told us something about its composition, its structure, its resilience. This was no weak visitor. It was built to last. Even if it wasn't built at all, the long goodbye 3i Atlas is leaving now. Each day, it drifts farther from the Sunday. Its coma fades, its chemistry cools, its jets sputter. Soon, it will be too faint to track, too far for our arrays to hear, too alone to leave more marks. And then, just a trajectory, just a line in a database, just a ghost in the sky. But in that fading light, we find something else. A reminder that truth is often quiet, that wonder doesn't shout. The most extraordinary things don't need drama to matter. They just need to be seen. We saw it, not the golden one, not the viral one, not the one misnamed or mislabeled. We saw the interstellar one, green, intact, real, and for a moment, just long enough we looked past the noise and into the truth. We owe it something. In the rush to correct the record to remind the world that the golden glow and the violent break belonged not to 3i Atlas, but to another, we risked doing something just as careless. We nearly dismissed C 2024 K1 as just the mistaken identity. But that comet, wrongly named, still earned our attention. Not because it fooled anyone, but because it performed. Let's return to it this time with clarity. Not as a stand-in, but as itself. And what we find is still extraordinary. A survivor, until it wasn't C 2024 K. One was never built to last. Its orbit kept it tightly bound to the Sun, an elliptical journey that brought it dangerously close during its perihelion. On approach, astronomers watched its coma thicken. They tracked a sharp increase in brightness. Dust began to stream outward. Reflective, dense, golden. This wasn't subtle fluorescence like 3i Atlas. This was scattering. Dust grains catch and flare light at visible wavelengths. The golden hue, likely fine dust made of silicates, iron sulfides, and organics materials that scatter red to yellow light more efficiently than blue under the sun's glare. The result? A tail that glowed like fire, a signal that screamed across the skies and into headlines. But that brightness was a warning sign. More dust means more stress. More sublimation means more venting. More venting means structural strain. This comet was working overtime, trying to survive its closest brush with the Sunday. And for a while, it did. The breakup, frame by frame. The end didn't come all at once. Using data from telescopes across multiple latitudes, observers watched the central condensation of C 2024 K1 begin to smear. The nucleus lost coherence. What was once a point became a glow, then several glows. Fragmentation had begun. The light curve wobbled, photometric profiles are blurred. Multiple fragments began to move with independent motion. This wasn't a dramatic explosion. It was slow, mechanical failure. Thermal expansion, venting asymmetry, spin-induced stress. The data told a simple story. The comet had passed too close. It had shed too much. Its core could no longer hold itself together, and still, until that moment, it had danced. It had shown us what dust evolution looks like in real time. It had painted the sky gold. That wasn't a failure. That was physics performing under pressure. Not an illusion, a lesson. The mistake wasn't seeing beauty. It was assigned to the wrong place. But the beauty itself was never false. C 2024 K1 did turn gold. It did fragment. It did tell a story of struggle, heat, and time. Its dust jets weren't viral lies, they were real physics. Its tail wasn't clickbait, it was the consequence of sunlight, dust size, and angular reflection. Its breakup wasn't drama, it was the final note of a performance it never agreed to give. Even its misidentification gave us something. A reminder of how quickly we leap to conclusions, how viral framing can overwrite origin. But when we return to the raw data, when we look only at C 2024 K1 on its own terms, we find something worthy. A comet that taught us. In just a few weeks, C 2024 K1 became a case study in Dust, coma, evolution, thermal-driven fragmentation, tail geometry across solar angles, photometric decay curves during collapse. It offered us a clean dataset on mid-size comet breakup, visible across multiple observatories, with enough temporal resolution to model failure dynamics in detail. We don't get that often. And it gave us something else. An emotional arc. It was bright, then golden, then fractured, then gone. That's not just spectacle. That's the physics of impermanence. A lesson about what light does to fragile bodies. A metaphor about endurance, failure, and timing. A real moment of truth beneath the noise. We remember it now properly, not as a viral illusion, not as a mistaken comet, but as C. 2024 K1, a golden survivor, until it wasn't, and in that, a comet that earned our respect the hard way. It's quiet again. No new headlines, no viral thumbnails, no comet stealing the stage. The sky has returned to stillness, the kind of stillness that only comes after a story finishes telling itself. And yet, something lingers, because once, for a brief moment, we thought we saw a golden visitor from another star. We believed it flared into brilliance. We watched it scatter, break, and drift into memory. That wasn't the truth. But it wasn't anything either. The difference between seeing and knowing, there's a kind of humility that only the sky can teach. It doesn't yell. It doesn't correct you in real time. You look, you think you understand. You build the story around the light. But sometimes the light bends. Sometimes the angle deceives. Sometimes two things overlap just enough to write a single false sentence across your field of view. We thought 3I, Atlas, turned gold. We thought it shattered. We thought we'd watched history break apart in real time. But that wasn't what happened. What actually mattered, 3I, Atlas stayed whole. It glowed green, not gold. It travelled quietly, not dramatically. And C, 2024, K1, never the interstellar one, gave us the real spectacle, the real fragments, the golden dust that turned heads and confused systems. Yet neither comet lied, only we did. Not maliciously. But by rushing, we connected the dots before we confirmed the coordinates. We wanted a narrative, not a nuance. But now that we know that the light has settled, we can see something else. A story not of error, but of how easily wonder can slip into assumption. What the sky still holds, there will be other comets. Some will flare, some will fade, some will break in silence, too distant for any telescope to witness. But each one will offer a new chance to slow down, to look closer, to wait before naming what we think we saw. Because the sky doesn't owe us clarity, we have to earn it. That means watching not just with eyes, but with patience, with discipline, with humility, and with a memory of this moment when two comets taught us the difference between drama and data, between glow and gas, between wanting and knowing. The light we carry forward, maybe we didn't see what we thought we saw. Maybe that matters. But maybe what matters more is that we stayed long enough to correct the frame, that we asked the harder question after the viral one passed, that we remembered to return to the original object, not the illusion, not the echo, but the source. We saw gold, we saw green, we saw the way light tricks us, and the way clarity restores us. We carry that now, like a map drawn in dust, a truth refracted through time. Because in the end, the sky doesn't just reflect the cosmos, it reflects us. And sometimes, what we think we see says more about who we are than what's really there.